Hi, good morning. My name is Hamadur Rahman and I'm a student of University of Wollongong. I'm doing Masters in Environmental Engineering and today I would be discussing resource recovery from wastewater as it is my research topic. Looking into the contents, these are my contents that I will be discussing it today. It's introduction, key points of literature, design question, then description of design, and at the last I'll be discussing advantages and disadvantages. Starting with an introduction. So the question arises, why are resources actually very important to recover from wastewater? There are many resources in wastewater like phosphorus, nitrogen, carbon, magnesium, iron, and many more. So these are it's very essential to recover those resources. Wastewater is the water that that comes from industries or domestic waste. So that is the wastewater, and it contains many resources, like I told you before. Resource recovery. Resources are the one that could generate energy. They are the one that they can give us like a good environment. If we remove resources from wastewater, we could have fresh water, and definitely contamination would not be there. So resource recovery works and it's also um, it also achieves sustainability in the productions. So coming towards my point, in resources recovery from wastewater, the point that I have chosen is like I'm working on phosphorus recovery from wastewater as it is very important. The phosphorus reserves are getting declined each year because of the population that is growing up like every year, and it has been estimated that in 100 years the phosphorus reserves will be no more. Phosphorus is the one that cannot be manufactured or synthesis by any means. So the only way the phosphorus can be recovered is by natural means, like you can mine it and then you can have phosphorus. The same thing is shown by here. It's a vital element, as I told, cannot be manufactured, and the threat, it's a threat to the future sustainability. Like if we cannot work on it, we could finish our reserves in almost 100 years. So the key points of literatures. First of all, in order to understand the literature, we should look into various benefits that phosphorus gives us. The very first thing is it fulfills the global phosphorus shortage. It fulfills the demands of the industries, of the agriculture, reduce contamination in water. It's important to human, plant, and animal. Various phosphorus recovery methods. There were many methods to recover phosphorus. I actually have mentioned 3 of them. So the very first is phosphorus recovery from steroid crystallization. In wastewater treatment plant, very often, during the treatment operation, steroid occurs, which forms in crystals. So if we recover phosphorus from steroid, we can achieve 70% from 70% phosphorus from steroid. The phosphorus produced from steroid, like that steroid has a quality of 99.5%. This steroid is an efficient technique, and it depends on the pH value. So like if solubility increases, pH decreases. So the another technique, some other methods and techniques are enhanced biological phosphorus removal method, which is used to recover phosphorus um, from steroid, and it is a cost-effective technique. The second one is phosphorus recovery from swine wastewater through crystallization. It can be done by using accumulation device. Steroid produced from this is 99.5% pure. As I already told that steroid is an efficient technique. Phosphorus recovered from steroid gives a good quality and good recovery of phosphorus. Phosphorus recovery from steroid. Steroid gives a valuable product which can be used as a, we can derive phosphorus from steroid, which can be used as a valuable product for fertilizers. Secondly, steroid occurs under under specific pH value. For example, the specific pH value for steroid is 8.0. If it exceeds from 8.0 to 9.0, it causes scaling in the equipment, and it is a huge loss in terms of cost, in terms of maintenance, etc. So it involves many reactors such as fluidized bed reactor, straight hang reactor, and agitated reactor for removal of phosphorus. Problems during formation of steroid. Steroid on one hand is very beneficial. It gives us a byproduct in terms of a fertilizer, like in terms of phosphorus, which can be used as fertilizer. But on the other hand, it is a very expensive problem as well. Steroid can cause scaling, it can cause falling, and dumping can occur into the pipes. Therefore, if scaling occurs, we all better know it damages instruments, it increases the cost of maintenance, cost of operation. So it's all about the issues that took place from steroid. Research question. So the basic objective of this research was to avoid scaling impact during steroid formation in phosphorus recovery. So research design focuses on four major terms, which are process control. In process control, what we do is like we control pH value. During the processes, there are many ions, so ionization takes place, and sometimes pH value gets increased, so we have to maintain the pH value as well as the temperature. We have to maintain the temperature as well. Secondly, there is chemical control. How can we do chemical control? We have to add some chemical dosing in it. Ferrous sulfate is the one that we use for maintaining the pH value, and we get a chemical control on steroid formation. The third one is maintenance and operational cost. By maintenance and operational, like it means we have to clean every equipment with the passage of times. We have to clean the pumps in order to avoid steroid. So the third one, last one is steroid recovery. We recover steroid as much as possible, and then we utilize it in the form of phosphorus byproducts. Here are some advantages. Appropriate control of steroid can reduce impact of scaling. Drawbacks. If pH exceed optimization value, steroid formation is uncontrolled and scaling occurs. This is my conclusion. In order to reduce scaling impact, four approaches of control plays an important role. So control formation of steroids should be achieved. Thank you.